So integration via parametric equation actually utilizes the same concept as the chain rule. So say we have this equation here, x equals t squared and y equals t plus 1. We need to find the area underneath the graph between x equals 0 and x equals 3. So how do we go about doing that? Well, we need to utilize this concept here. So we know that y dx, the integral of y with respect to dx, is equal to y dx dt with respect to dt here. How does that work? Well, utilizing the same concept as the chain rule, these dt's actually cancel out, quote unquote cancel out, and that leaves y dx equaling y dx, which is the same thing. So let's actually use this concept in this question here, and it will make a lot more sense from there. So there's 3 steps that you need to take. You need to find dx dt, and then you'll need to integrate it with respect to t, and then you'll need to change the limits and then find the final value. So first of all, we need to find dx dt. So we know that x is equal to t squared, and dx dt is just differentiating with respect to t, which equals 2t. Now we need to integrate. So how do we go about integrating? We utilize the second right hand side here. So y is equal to t plus 1. Multiply that with dx dt, which we just found, which is 2t, and we integrate that with respect to t. So this equals the integral of 2t squared plus 2t dt, and integrating that equals 2t cubed over 3 plus, or 2t squared over 2, which just simplifies, plus c, which simplifies down to 2t cubed over 3 plus t squared plus c. Okay, now that we've got that, we need to change the limits here. Changing the limits is actually as simple as writing a table like this, finding x, and then we have t here. So we know that x equals t squared, so when x equals 0, t is going to equal 0. That's pretty obvious. When x equals 3, t actually is going to equal square root of 3, because it's t squared that equals x, not the other way around. So you can get confused here, and you can write 9, because it's not going to be x squared equals t, it's actually t squared equals x. So just be a little bit careful about that. So now let's find the limits between that. So 2t cubed over 3 plus 2t squared, or actually just t squared like that. And I can get rid of the c because the constant actually cancels out. So we have root 3 as the upper limit and 0 as the lower limit. What does that equal? So it's going to be 2. Root 3 cubed is going to be 3 root 3 over 3 plus root 3 cubed is just, squared is just going to be 3. So that equals, the 3's cancel out, so it's going to be 2 root 3 plus 3 as our final answer. And that's it for that question. So we got another question from Mr. Bison Maths. It says curve C has parametric equations x equals t multiplied by 1 plus t and y equals 1 over 1 plus t, where t is greater than or equal to 0. We need to find the exact area of the region R bounded by C, the x-axis, and the lines x equals 0 and x equals 2. So how do we go about doing this? Well, actually, we need to first find what dx dt is. So x equals t. I'm going to just expand the brackets here. So t plus t squared. What's dx dt going to be? Pretty simple. 1 plus 2t like this. And then we have the integral of y dx by dt. And this equals, so y just equals 1 over 1 plus t. And we have dx dt equaling 1 plus 2t. And then this is going to get integrated with respect to t. So this equals 1 plus 2t over 1 plus t dt. So we can't split the numerator here, and we can't split the denominator here. So what we need to utilize is algebraic division. So how do we go about doing that? So this is 1 plus t at the bottom and 1 plus 2t at the middle here. You need to be a bit careful here, because what we're trying to get rid of isn't this 1, but we're trying to get rid of this 2t. So we need to multiply this by 2. So this becomes 2 plus 2t. And we get like minus 1 left behind. So this is the same as saying 2 remainder 1, minus 1, sorry. So this is the same as saying 2 minus 1 over 1 plus t. So this equals minus 1 over 1 plus t like this, dt. This just equals 2t minus ln of 1 plus t in the middle there, plus c. Okay, and now we need to change the limits. So changing the limits is because x equals 0, and 2, and then t would therefore equal 0 when x equals 2. So 2 equals t plus 2 squared. So t squared plus t minus 2 equals 0. So this is t plus 2, t minus 1 equals 0. So t equals 1 or minus 2. Because we know that t is greater than or equal to 0, t equals 1 there. So from here, we need to find the limits. So sorry, we've already found the limits. We need to utilize the limits to help us find the final value. So this equals 2 minus ln of 2 minus, and then this is going to be 0 minus ln 1, which is also 0. So our final answer is actually just 2 minus ln 2, and that's it. So this is our final answer then. So I'm going to do one more question that I've taken from exam solutions just to get another example out for parametric equations. So we have this question 7 here. It says figure 2 shows a sketch of the curve C with parametric equation this: x equaling 5t squared minus 4 and y equals t multiplied by 9 minus t squared. So the curve cuts C at the x-axis, point A and point B. So here and here. We need to find the coordinates of A and the x coordinate of B, because obviously the y coordinates are also going to be just 0 from which for part A. So how do we go about doing that? So actually we know that y equals 0, so we can just plop that into the equation there. So for part A, we need to utilize the right hand side. So y equals t multiplied by 9 minus t squared, like this here. From here, I can actually see the right hand side is actually just going to be the difference of 2 squared. So 3 plus t, 3 minus t, like this. And we also know that y equals 0 at both those values. So this equals 0. So t will therefore equal 0, minus 3, and plus 3. So we have x equals 5t squared minus 4 because we actually need to find the x value. So the first value is when t equals 0. So x equals minus 4 at that point. And it makes sense that a is going to be minus 4. So we have a equals minus 4 when t equals 0. When t equals minus 3, what does this equal? Well, let's do t equals 3. So x equals 5, 3 squared minus 4, which equals 9 times 5, which is 45, minus 4 is 41. If we had t equals minus 3, what would our answer be? Well, actually, it would just be the same thing because x equals 5 times minus 3 squared minus 4. Minus 3 squared is just going to be 9 again. So 9 times 5 is 45. 45 minus 4 is just 41. So it's really important that we saw that t also equals 0, not just 3 and minus 3. Because sometimes people can actually just divide by t from here and just get 9 minus t squared. And that will mean that we don't actually get the other value of t. So we have b equaling 41. So a equals minus 4 and b equals 41. So part B, we need to use integration to find the area of R enclosed by this loop here. So we found a and b, the two values of a and b. So part B, so the region R as shown shaded in figure 2 is enclosed by the loop of the curve. So it's this whole thing here. So you need to use integration to find the area of R. So first of all, what do we need to do? We need to find dx dt. So dx dt is equal to, we know that x equals 5 squared minus 4. So dx dt is actually just going to equal 10t. Pretty simple. So now we need to integrate y dx dt with respect to dt. So this equals, well, y in this scenario in terms of the parametric equations equals t 9 minus t squared, and dx dt just equals 10t. And we have to integrate that with respect to dt. So this equals integral of, actually we can just put the 10 on the outside like that. And then we have 9t squared minus t to the power 4 dt. So this equals 10, open brackets, 9t cubed over 3 minus t to the power 5 over 5, and then the plus c at the end there. This equals, this is 1, this is 3, this is just 5, so 30 t cubed minus 2t to the power 5 plus c. So now from there we need to find the limits. So what's the limits going to be? So to find the limits of t, we actually already found it in A. So we know that x equals minus 4 at that point and x equals 41 at that point. So the lower limit for t is going to be 0, the upper limit is going to be 3. So this is between 3 and 0. So this equals 30, 3 cubed minus 2 times 3 to the power of 5 minus, and then it's just going to be 0 actually. So this equals 30 times 3 cubed minus 2 times 3 to the power of 5 equals 324. So this is our answer for R. So we have 324. This typically only accounts for the top part between the x-axis and the curve region here. So we have to actually times this by 2 to account for that region. So this times 2 gives us our final answer, which is 648, like that.